Hello everyone. Today we're going to talk about lines, rays, and planes. And we finally have enough vector background to build these up in a way that's going to be very helpful for us when we get to the ray tracer. So you probably got beat over the head in high school with lines at some point. Some y is equal to mx plus b kind of stuff, right? Either in some geometry class or some algebra class. And they probably also hit you over the head with that on the SAT. Okay. So maybe you don't love lines. But we're going to look at them a slightly different way, which will allow us to interpret them hopefully in a way that meshes with what we've talked about so far. So I'm not saying forget everything you've done, but certainly if you have any negative associations, try to put them aside for a moment. And we'll start with a clean slate here. Okay, so we're going to define lines two different ways. The first way is called the parametric way. Ooh, fancy parametric. All it means is we're going to have a single number that tells us how to walk along a line, and we call that our parameter. Okay, so mathematicians like to sound very fancy, but that's all it is. So let's talk about that. So to define a line with a parameter, what we have to do is say, okay, let me take some point on that line, any point. I'll call that P0. So I'm going to start to conflate vectors and points a little bit, but I'll keep the arrow just to remind us that this is something that has coordinates, okay? So it's an initial point, and I'm now going to also have a vector that I need to specify up front. That vector is going to tell me the direction of the line. So I'll call that V. Okay, now how do I reach all of the points along the line? So actually with these two pieces of information, I can get you to any point I want on the line. And so I'm saying, here's the line that this point and this direction define. And the way that I get to all points is I say, okay, well, let me try to choose a point P, which is going to be a function of my parameter T. And T is just going to be a scalar. So I'll say P of T is equal to, okay, so we're going to start at our initial point on the line. And then what we're going to do is we're going to walk along this direction. And that can be expressed as our parameter T as a scalar multiple in front of the direction V. So here's the equation. So this is our equation for the parametric form of lines. P of T is equal to P0 plus TV. Okay, so remember that. That's going to come up over and over again. So just as an example, let's look. So what if T is equal to 1? Well, then I'm just saying that's just going to be P0 plus V. So I start at P0, and I add on a factor of V, and I end up at the tip here. Okay, so that's for T equals 1. But I can walk all over this line. I can actually keep going. I can say, well, what if T is equal to 2? Okay, well, in that case, I'm going to end up at twice this vector. So if I do that, then that's like saying, okay, start at P0 here and now walk even further. So that's T is equal to 2. Or alternatively, you could see it as, let me put on one factor of V and then another one. So V plus V is 2V. And then the point that I end up with is at the tip here. But I can get to all points on the line. So, you know, I don't have to choose an integer. I can certainly choose 1.5 as well. And then that'll be, you know, halfway in between the 2 points I showed you before. So that would be, so here's T equals 1. Here's T equals 2. So I'll just label them here. So this is T is equal to 2, T is equal to 1. And then right in the middle there, we're going to have T is equal to 1.5, right? Somewhere around here. So notice as you vary T, you can go to different points, but they're all going to be on this line because they're fixed to be going in this direction here. I can also choose T to be negative, right? If I say T is equal to -1, well then that's just saying I'm going to start at P0 and I'm going to subtract V now. So then I'm just saying, well, let me flip the direction of this arrow here. I always get this wrong. Okay, there we go. So this is going to be, if I say p0 and I have a t of -1, so that's just going to be p0 minus v. So I can hit up all the points on this side too. So that's how I can get to all points on the line. It extends to infinity. So what we're really saying is, for a line, t is somewhere between negative infinity and positive infinity. Okay. So lines are infinite as we define them. Line segments are finite. That was something my geometry teacher in high school really hit me over the head with. Okay. All right, but we can define something else, which is array, which is very similar. Array can be defined exactly the same way parametrically, but we just say that in this case t is greater than or equal to 0. So we don't allow a negative t. So if we don't allow a negative t, then we're never going to go behind this endpoint. And so we're only going to walk forward along this direction, and that's what's referred to as array. Okay, so that's all you need to know about the parametric form of lines and arrays. So just as a sanity check, we're going to do a quick exercise on that.